Hello and welcome to my channel. This session will cover clutch construction and operation. This is aimed at level 1 to level 2 students who are currently at college or on apprenticeships. So this will cover manual clutches, and as you can see at the bottom there we have three main areas, which are clutch construction components, basic clutch operation, and some different types of clutch operating mechanism. So, why do we have a clutch? Well, in terms of a manual clutch, these are usually used with manual transmissions, such as the vehicles you see with 4, 5, 6 gears, for example, and a gear stick. The first thing it's going to do is provide a link between the engine and transmission. So the engine's rotating, and we want to rotate those wheels, so we need to connect them in some way. It also allows us to have a smooth take-up of drive. So as we release the clutch, those of you who drive, you'll know that the slower you release it, the smoother you start off. Another point of the clutch is to give us a brief separation between the engine and gearbox. For example, if we want to change gear, or we want to put it in a temporary state of neutral, if we're stopped at traffic lights or a junction waiting to pull out. So, covering that first section, question 1, which of the following statements about clutches is true? Do A, all vehicles have clutches? Do B, clutches link the wheels to the transmission system? C, clutches allow the changing of gears? Or D, clutches do not allow the vehicle to stop in gear? So which of those is true? Okay. Well, the answer, if you've not already got it, should be clutches allow the changing of gears. C. Remember, we're talking about manual transmission systems, not automatic. So, moving on, clutch action. So, the diagram here demonstrates how a manual clutch works, and it can be demonstrated by these two discs, which could be friction discs. We have a drive disc which is attached to the engine, and then we have a driven disc which is attached to the transmission input shaft. Okay. Now when these are disconnected and not in contact, there's obviously no drive. But if we clamp these two together, we can then apply drive. So this is basically what our clutch is going to be doing. So if we look at an actual clutch, the flywheel is the driven plate that was attached to the engine in the previous slide, which I'll go back to in a moment. The clutch plate, or the driven plate, some people may call it a friction plate or a spinner plate, that is the part that's going to be attached to the input shaft and is a driven plate, which will then drive the gearbox. We then have a pressure plate assembly, or some people may call that a clutch cover. That is going to have a spring mechanism in it that's going to clamp the clutch plate against the flywheel so we get drive. And when we release that, we can get that temporary state of neutral. We will then have a release bearing, which when we activate our clutch by pressing the pedal, will press down on the pressure plate assembly and release the clutch. We then need a clutch fork, which is very important, believe it or not. That gives us a lever in effect, and gives us a lever effect so we can apply more force to the pressure plate. And then all this will be covered by clutch housing. Now if I briefly go back to the previous slide, we can see here that the driven disc in the top diagram, that is our flywheel, and the driven disc is the clutch plate or friction plate, which is then slotted onto the input shaft. Okay, so question 2. Which two parts of a clutch system are next to each other? So in that previous diagram, which two parts were next to each other? Were the clutch fork and flywheel next to each other? The clutch plate and clutch fork? C, the release bearing and flywheel? D, the flywheel and the clutch plate? So which two components are next to each other? So you should of course get D, which is the flywheel and the clutch plate, because they are the two components that will be clamped together to transmit drive. So if we look at the clutch plate in a bit more detail, so this will be located between the flywheel and the pressure plate. On the centre, there is a splined hub. So the splines are the little slots you can see where it will slot onto the input shaft. And this is a really efficient mechanism of slotting something onto a shaft that we want to rotate so that it doesn't slip. Friction material, which is similar in many ways to brake pad material, that is riveted together. So we've got two sides of this clutch. It's a two-sided clutch, two friction faces. And in between there are cushion springs, which we'll see in a moment. The cushion springs are between the two friction surfaces. And basically when you look at these, they look like just one small piece of metal that's got a little bend in it. But actually, again, it's another important feature. If we didn't have this, the friction plate would be solid. And every time it clamps and unclamps, it's going to be subject to a small impact, which could eventually fatigue the component and damage the component. So this is going to absorb a little bit of that impact. And we can see in this diagram here, we've got a section removed and we can see the cushion springs. You may look at a lot of different clutch plates and they may slightly different design, but they all essentially do the same thing. Another aspect of clutch friction plates is we have these torsional springs in the centre. So those of you who drive, as you know, if you let the clutch up too fast, you get a bit of a jolt and it jerks forward. This is going to load up your transmission, load up the crankshaft, and over time it's not really going to be very good for the engine or the components. What these springs do is absorb some of that torsional load as the clutch engages. You may see some older design clutches on older vehicles that have kind of a rubber torsional spring instead of these coil springs. So, question 3, to recap, what is the name of the springs in the clutch plate that are positioned between the friction plates? So between the friction plates, do we call those A, the tension springs, B, the cushion springs, C, the torsion springs, or D, the compression springs? So if you think back to that previous diagram, these are called the cushion springs. It's to absorb that engaging impact. Number 4, why is the hub of the clutch plate splined? So that was the little slots that are in the centre of the clutch plate. A, because it's easier to lubricate. B, because it can never be undone once fitted to the shaft. C, because it is an efficient way of stopping the hub rotating on the shaft. Or D, because it makes a high friction join. Okay, so if you know anything about splines, you know it's a very efficient way of locking something in place. So the answer is C, an efficient way of stopping the hub rotating on the shaft. Okay, this is our pressure plate assembly. And as you can see, it has a smooth surface on one side and these little slotted metal pieces on the inside. There are two types of these. The most common type that is on the vast majority of light vehicles, if not all now, is the diaphragm spring type. And that is the type you can see in that diaphragm there, in the clutch cover there, sorry. And those little slotted pieces of metal in the middle are actually springs. The coil spring type you may find on some heavier vehicles or older vehicles. There's a lot of disadvantages to coil springs, which is why we moved away from them. So we've got our spring assembly in the centre there. We have the pressure plate, which is a smooth disc. And we have the cover, which holds all these pieces together. The coil spring type used, as you can imagine, coil springs, which work, but there are a number of disadvantages in terms of coil springs generally fatigue over their lifetime. So as the clutch ages, these springs get softer and are unable to clamp the clutch as well as they did when they were originally built, which possibly means your clutch could slip. They're generally a heavier component, And another issue with coil springs is as you compress a coil spring, it gets stiffer and stiffer until it becomes coil bound. Now in a clutch, a manual clutch, that wouldn't be advantageous. You can imagine as you press your clutch pedal, it's going to be getting harder and harder. The interesting thing about diaphragm springs is when they get to a certain point, they pop through to the other side, if you like, and your clutch becomes progressively easier as you press them. So, number 5, what is the part called that pushes the clutch plate onto the flywheel? So we've got A, pressure plate assembly, B, release bearing, C, clutch housing, or D, the torsion spring. So the answer for that one should be A, the pressure plate assembly. That is the part that pushes the clutch plate onto the flywheel and then we can transmit drive. So the second part of the clutch assembly is the actual diaphragm spring and pressure plate assembly. So as you can see there, it's a bit of a dish shape. If you view it from the side, you can see those diaphragm springs are popping up a little bit. Now, as we push down in the centre area of that, and you can probably see where my pointer is, there's a little bit of a wear patch there, and that is where the release bearing is going to make contact with these diaphragm springs. That is going to push down on that, which first doesn't seem to make sense because that would mean you're clamping the friction plate harder against the flywheel. But what happens is if you look at this bottom diagram, as we press these centre parts here, they pivot on this part, and actually these bits of the diagonal line through lift, okay, and it lifts the pressure plate away from the friction plate. So number 6, how many different types of pressure plate assemblies do we have? 1, 2, 3, or 4? So the answer is 2. We have the coil spring type and the diaphragm spring type. So I just mentioned in the previous slide a release bearing. So this is a release bearing in this profile view. And that is attached to one end to the clutch fork and makes contact with the diaphragm springs, which you can see with my pointer here. As the clutch fork moves, so this is going to be activated by a clutch pedal via a cable or hydraulic mechanism. What it does, it pushes the release bearing to the left, as you can see, pushes down on the centre of those diaphragm springs, which pivot and lift the pressure plate. When you release the clutch, the fork moves in the other direction, releases the bearing, and the clutch plate is clamped back down again by the springs. So you can see the springs are a very important part of this mechanism. We need a lot of clamping force. And again, another advantage of diaphragm springs is that a very light weight and less material, we've got a very powerful clamping force. I mean, if you get one of these in your hand and you try to push it down, you're not going to move it. You need a lot of force. Question 7. Which part is directly connected to the clutch fork? A, the flywheel. B, the release bearing. C, the clutch plate. Or D, the pressure plate. So which part is directly connected to the clutch fork? So the answer for that is B. The release bearing is connected to the clutch fork, which then pushes down onto the diaphragm springs. Okay, so let's look how the clutch actually operates in practice. So in the diagram here, we've got a foot pedal, which operates the clutch fork via a link. And in this case, we've got a cable link, if you like. When we release the foot pedal, the clutch is engaged. So when you depress the pedal, as in lift the pedal, the clutch is engaged and is clamped. The pedal action has to be smooth or we're going to get some kind of clutch judder. So in terms of cable mechanisms, one issue with cable mechanisms is as they age, they can be prone to sticking. The pivot mechanisms and the pins in these mechanisms can wear and we can get unsmooth clutches. Okay, so the clutch pedal has got to be easy to operate. So if you can imagine you're stuck in a traffic jam and you're edging forward every 10-15 seconds and you're putting your clutch down, you're lifting it up, a heavy clutch is not going to be very comfortable in terms of driving. So how do we do this? Well, we use a combination of levers or hydraulics. In terms of this diagram, we have got levers and the cable mechanism. So we can put some numbers in here to see how this works. So we've got 100 newtons of force at the pedal. That's the force we're applying with our foot. And we have a pivot ratio in the pedal, because it's a lever, of 3:1. So what we do with that is multiply the 100 by 3. So we're now getting 300 newtons being applied to that cable mechanism. That 300 newtons is pulling on the cable, which then pulls at this end of the clutch fork. And that's 300 newtons. We then, in the clutch fork, that gives us a pivot ratio of 4:1. So we can amplify that 300 or multiply it by 4. We then get 1200 newtons. So from 100 newtons at the pedal, we're now getting 1200 newtons. So 12 times the amount of force we put in by our foot at the release bearing. So that is the clutch mechanism and why it is very important that we use these levers. So it makes our clutch pedal very, very soft. So we can now have a very powerful clamping effect on the clutch to prevent slip, but still have a relatively easy pedal. So question number 8. What are the clutch pedal and the clutch fork both examples of? Are they A, pivots, B, operators, C, diaphragms, or D, levers? Okay, so remembering back to the previous diagram, they are examples of levers, D. So this is our mechanical operating mechanism. This is a bit of a better diagram to show how it's connected. And this is a cable. So many manufacturers use cables for years and years. Some of them still use them. They're probably a little bit cheaper to manufacture than hydraulic methods. And they're relatively simple. There's also a little bit of adjustment required when you fit these, or the cable starts to stretch. So it's a multi-stranded steel wire cable, similar to any kind of cable you find on a bicycle cable for the brakes or the gears or anything like that. And it has an outer sheath, which is this black part here. So when we press our pedal, it's going to pull on that cable, and it's going to pull the clutch lever here, or the clutch fork, and press down on those diaphragm springs. This system here has a return spring, so when we let go of our clutch, it helps return the pedal or the clutch fork to its original position. Now, good points about these: they're cheap, they're lightweight, pretty simple in operation, but there are some down points. First of all, at the pedal side and the clutch fork side, there is some adjustment, and if you get this misadjusted, you're either going to have a high pedal or a low pedal, and this could also result in bad scenarios like clutch slipping or clutch dragging, which is going to weigh a clutch out a lot faster. So they do have to be set up correctly. Another downside is that the cable isn't going to last forever. Especially when we go in these tight bends here, where you can see my pointer, it's going to act like a bit of a cutting action. And as these get older, the outer sheath can get damaged, especially if there's tight bends. So if you're fitting these, you want to have no tight bends in the cable whatsoever. And they'll eventually stick. Sometimes this can be misdiagnosed as an actual clutch mechanism problem, when actually it could be simply a cable problem. So, question 9. What material would be used to make a clutch cable? Would we use A, steel, B, cast iron, C, aluminium, or D, copper? So we look at these materials. The only one that really works is A, steel. It's a very strong wire. If we look at some of the others, cast iron going to be heavy, it's going to rust very easily. It's not going to have the same strength as steel in terms of tensile strength. Aluminium is a soft material, and copper is a very soft material. In fact, copper strands, you can snap those yourself with your hands if you pull hard enough. Okay, now the mechanism a lot of people will be more familiar with if you look under the car bonnet is a hydraulic mechanism. So this is very, very common now. It's a little bit different in terms of its operation and its adjustment. So what we've got is two cylinders. On the top there we have a master cylinder. That is the one where you top your fluid up or fill your fluid. This works very similar to a brake master cylinder. The bottom one is the slave cylinder, or the secondary cylinder. That is the part where the piston is going to pop out and activate the clutch fork. So if you're familiar with hydraulic brakes, it's a very similar mechanism. As we depress the clutch pedal, the master cylinder builds pressure in the system. It pushes fluid through the pipe and activates the slave cylinder, which pushes that out. As we release the pedal, the springs return to the rest position. Now you can see some advantages of this. There's no cable to wear, there's no corrosion, there's no adjustment if you like. The only thing you need to do is, if you fit these components, is make sure you bleed the system, that there's no air trapped in it. They are subject to leaks when they get older, especially the slave cylinder. If you ever find wet fluid around the slave cylinder area, it's probably the seals leaking. They're usually quite a cheap and easy fix. Sometimes the slave cylinders, as they get older, suffer from squeaks, and they're not very quiet, which some people don't like. You will find that, unlike brakes, this is often skipped on servicing, and a lot of people skip over and don't change the fluid. So if you find yourself a car that's 10 years old and it's never been changed, the fluid, you look inside, it's probably going to be all murky and dark in coloured. Your clutch may still operate, but bear in mind that that fluid is contaminated, usually with moisture, and it's going to be corroding the inside of the system. So you don't get clutch failure when you're out and about, really you should change this fluid as part of your servicing criteria. So question 10. Automobile clutch operating mechanisms can either be mechanical, pneumatic, or hydraulic. True or false? So the answer for that is false. If you look at the basic words there, pneumatic means air operated. Now I'm not saying that doesn't exist on some vehicles, but on light vehicles, at the very least, the hydraulic, which is now the most common, and mechanical is the cable operated mechanism. So summary, what have we covered? So we've looked at the main clutch components and construction. We've looked at the basic operation of the clutch in terms of clamping effect and how the springs operate. We've also looked at the main clutch operating mechanisms, hydraulic and cable mechanisms. So that's the end of this video. A good way to use these videos would be to go through them, pause it on the questions and try and answer the question yourself before I've given the answer. So thanks for watching, and hopefully we'll see each other next time.